This
But here's
conference
just
will
a kind of
now
a
be
variety of
recorded.
different parts that we see, come and go. Some of these are demo parts, plastic injection molded parts. I know a lot of you guys are molding plastic. This is a 3D printed part, and then a variety machine parts here, some stamp parts. The principles, though, that we're going to talk about, they apply no matter what type of a part it is. There might be some challenges based on the geometries on your part, but that's kind of why we're doing this today, so you can have some reference point to start from. And then, of course, as you actually start to measure your own parts and you have your own unique challenges, that's where we would hope to have some feedback from you. Know that we're here for that purpose. So there's quite a few resources with Zone3. I hope that all of you are signed up to the user forum, which is at zone3.zone. Anybody with a machine serial number with a valid license of Zone3 can have as many users as they want on this forum. It's hosted by QBI. So their applications engineers, their software engineers are going to be the ones actually answering the questions. And then there's a ton of useful information. It's a great place to start if you have questions. But again, don't hesitate to lean on us. Ultimately, it's that initial ramp up of knowledge that we would like to help you guys get through. And then when you have the more difficult challenges, that's what we're here for as well. So today we are going to talk about importing 3D CAD models and aligning to them, creating a full datum alignment. So what I kind of want to discuss is some of your options when importing models, okay? Like I said, we'll look at this one to start, and then if we have time, we'll take a look at this DXF model here, okay? Because that's going to be handled just a little bit differently and a little bit more options there. I'm going to turn around and look at the software here. I'm going to place my part right on my stage. I would recommend securing your parts, okay? These are parts sitting on a smooth glass plate, and they want to slide around because of lack of friction. So either you're going to be holding these parts in a fixture, or you're going to be holding them, securing them to the stage somehow. Two-sided tape is your friend. Putty, just simple tacky putty to hang a poster on your wall. But we need some way of holding the part from moving, because if I measure the part here and it shifts a little bit this way and then I measure it again, I'm not measuring the part anymore. I'm measuring how far it moved. And that's not what I'm trying to do here. So be sure to hold it down. I've got a little two-sided tape, and I'll secure it to the stage right in the middle there. And we are ready to go. Okay. So I've got my software open. You can see here, this is Zone3 version 10.0.20. It's kind of the latest version. You might see some slight differences in your version of the software. But again, just kind of take notes. We can handle those offline. I know there's a lot of different varieties of the software being used. The very beginning of writing a Zone3 program with CAD in Zone3 Pro or Prime requires me to first import my CAD model. And we have some different options here for what kinds of CAD we can import. In the latest version of the software, we can import even native files, solid part files, that kind of thing, and PMI files, which are product for manufacturer information files that have all the nominals, tolerances, and GD&T built into the CAD model itself. But today we're going to be dealing with step model. So the first thing I want to do is go up to my top left ribbon here. This is my getting started ribbon. The ribbons are these little drop downs. If I click on an arrow, the ribbon drops down. You'll notice that the ribbon is divided kind of top and bottom here in half. And all that allows me to do is if I click the bottom, it drops the ribbon down to show me my options. If I click the top half, it is going to select the current feature up there. So in this case, the feature finder or a point. So the getting started ribbon here, I want to import CAD. Okay. So if it doesn't instantly go to this file location, you might have looked for a model somewhere else. Just kind of take note here. These models, when you load the software, are stored at the C drive, users, public documents, QVI models. Okay, maybe if you're going to be working with these models a lot for practice purposes, maybe make a little shortcut on your desktop, and then it's a little easier to find. You can see down here, these are the supported file types. So if you are not using version 10 of this software, then you won't see all of these extra file types. They were using kind of the agnostic IGES and step files, DXF, but now we have a lot of different options. So that's one of the upgrades to version 10. For those out there considering going to version 10 or upgrading to anything at any point in time, feel free to reach out to us and we can send you documentation on the improvements that have been made from major revision to major revision. And QVI does a very good job of kind of putting value-added improvements in the software. It's not just bug fixes and things like that. It's actual tools and things like that. So don't hesitate to reach out. So today we're going to be working with a step file. These are the preloaded demonstration files. So I have the ZONE3 training part in a couple of iterations. The printed circuit board deals with the little circuit board on the model. I'll show you that in a second, so we can treat those as separate things. Treat this as a DXF. We have a DXF file, which is a 2D wireframe CAD model for that flat fast start part, that black stamped Measure X part. And then we have solid models for the red part and the flat stamp part right here. We are going to be working with the ZONE3 training part, Rev B step file today. Okay. So I'm going to double click on that or hit open, and it's going to import my CAD model. Now, when we import the CAD model, it's going to ask us what units this CAD model was built in and what units we should import it in. This is important because if I bring in the model in the wrong units, you're going to see a scaling issue. Okay. So if I turn off the machine model right up here, I can see or not see the machine model. If I turn that off, I might think, hey, it imported correctly. We're good to go. If I turn the machine model on, however, I can see that this part was drawn in millimeters and I imported it in inches. So it is quite a bit bigger than it actually should be. So I can hit cancel and bring the model in correctly. Okay. So that's kind of one of the main reasons that we have the ability to look at this machine model here. It doesn't offer a ton of value outside of that. So typically once I get my part model in and aligned how I want it, I'm going to turn that machine model off. It's also pretty helpful for programming offline because you sometimes don't know what your sensor offset. So in the case of this machine, I have a touch probe on it here, offset from my optical axis. It's nice to be able to manipulate that model relative to the machine to see if I'll have enough travel to be able to use my different sensors. So I'm going to go ahead and re-import that CAD, and I'll do it correctly this time. And once I do, okay, it brings the model in, and there it is. It looks and appears to be scaled correctly, but it's just going to bring the model in to wherever my machine origin is right here. So that's not a big deal. We can always update the location of the model, and we will as soon as we start to measure it, as soon as we start to create a measured alignment. But here's where we have to make some choices, okay? We've got a couple of different things we can do and a couple of different ways we can start a program. In MeasureMind and Measure X, if you came through training here at PQI, excuse me, you probably work with me, and I probably told you to do this one way. So for example, on this red part, I would probably have told you to find this lower left corner and focus on it with backlight and take a crosshair target and align it to that corner, and we would zero out X, Y, and Z in our DRO, our digital readout, and then drive over here and use this corner to rotate the, to set the skew of rotation for the part. That's called a part setup, okay? And that's basically a way for us to teach the machine where the part is on the stage. When I set a part down on this stage or on any measurement machine, it doesn't know where the part is. Now, there are some large field of view systems like our Snap or a Kiosk that have a big enough camera view, they can look at that part and say, I know where it is. I'll start measuring it right here. So they can tell where the part is and how it's oriented rotationally. But with a large field of view system, which is a more common type of multi-sensor system, we're only ever looking at maybe 1/3 of an inch by 1/4 of an inch at low mag. So obviously that's not enough field of view to see a big part like this. So we have to tell the machine where the part is, both in X Y, and Z, but also how it's rotated, okay? So those are kind of the critical things we got to do there. Now, how we want to start our program is completely up to us. Whatever you're more comfortable with. We have a few different options that we're going to talk about today. But the first one is to use a part setup alignment. Okay. Now, part setup alignment is very similar, or I guess the same as what you were doing in Measure X or Measure Mind. Okay. In our part setup alignment, we are going to tell ZONE3 where on the model we're going to zero X, Y, and Z, and where on the model we're going to skew our X axis through. Okay. So in this case, I'm going to find a feature on this model that would be easy for somebody to align to. So if we're looking at this part, I'm going to use this corner right here, so that little intersection for my XYZ origin, and then this little corner over here to set my rotational skew. I'm just choosing those features because they're easy for somebody to put a crosshair target on and align to it, okay? You could use this corner and this corner if you had nice corners there. Whatever you want to use. This is not going to be our datum features. This is going to be two features that help us locate and orient the part. So the process goes, I'm going to stage my part, put it on the stage. I'm going to think about where I put it on a stage, because if I need to use touch probes and those touch probes are offset from my optics, can I reach all the features I need to reach? So I go and test. Oh, it looks like I might want to move this over a little bit because my touch probe might not be able to get to all those features, okay? So things to think about. If you're not using a touch probe, don't worry about it. And now I'll turn my machine model off because, again, I feel like I imported it correctly. And I am going to look right below my model window here and click on this manual part setup. When I click on that manual part setup, I'm indicating to the software that I plan on using my digital readout up here to locate and orient the part like I've always done in the past. So in my little menu down here, it says select the location on the CAD model that will be used to zero the part on the machine stage at a specified point. So they're saying where on this model will be your XYZ origin. So if I click on a feature like this intersection, it moves my origin there. So what I just told this machine is I will go and find that location on my part before I make any measurements, and I'm going to zero out in my DRO X, Y, and Z up here. And then it will marry that location to the model. So it'll basically move the model to where the part is in the software. And then the second option down here is select the location on the CAD model that will be used to align the machine stage's x-axis to a specified point. So right now it's aligned along, the x-axis is aligned along this edge right here. If I click on that, it's not going to move. Oops, I first got to switch my radio button down here. So if I click on this little intersection, it's not going to move because it's already aligned along that edge. If I click on this circle here, though, look, it rotates the x-axis through the center point of that circle. So I could do that if I wanted to. But in this case, I am going to use this little intersection here. And I've just told the machine that I am going to perform that part setup before I run the program. This allows me to run this program or this part program from anywhere on the stage in any orientation, so long as my sensors can get to the features I'm trying to measure. I also have down here an option for performing a manual part setup and putting some instructions in there. So I could say align to wherever and skew axis, okay, or whatever instructions you want to put in there. The other really nice thing that I can do in here is I could put an image in there. So I'm just going to quickly take a snip of this, and I'll just do some quick marking up. Let's say I'll use this red pen, and I'll circle that, and I'll circle that, okay? You could mark this up however you want, be as creative as you want. I'm going to save this to the desktop, and we'll call it Align Test. Okay, so now what I can do is in my little part setup instructions window, I can right click and say insert image. The image source file, I can go and locate that. I put it on the desktop. And now Where did I put it? Right here. Now when they go to run this program, there's going to be this image in here. So I'll just save that. Now watch what happens when I hit run. This nice image pops up. I can make this little header bigger or smaller. And then I could have some text in there to also further help somebody align to this part. It's all about giving you more information than less. That was always one of the shortcomings, I think, of the kind of legacy softwares, MeasureMind and MeasureX, is, you know, information is power. If somebody's going to walk up to one of these machines, they don't necessarily know what you did. And so there's a lot of assumptions baked into how you program and that kind of thing, and whether or not somebody's going to have much luck running your routine or getting it to work. So the more images, text, you know, links to videos, that kind of thing we can build into the program, the easier it is and the better luck somebody's going to have running a program. So this is a quick completion of this process now. In order to locate the part, I put my origin there. I need to still deal with the DRO portion of this. So what I'm going to do is I'm going to grab a crosshair tool and turn up some top lighting and come over and find my part. Okay. Okay, so that is the scallop on that part. That is this little intersection right here is what you're seeing in the camera window. One thing I want to note, though, is do you see this little cube kind of floating off in space over here to the right of my model window? That is my field of view. So the machine actually shows my field of view, and they're not in agreement right now. So my field of view in my camera window is looking at the part, that little corner, but in my model window, it's floating off in space because the machine doesn't know where the part is on the stage. I haven't told it yet. But watch what happens as I start to zero things out. So I'm going to zero the x-axis out. And it moved over here. You can't see it, but if I make this transparent, now it's kind of floating inside of the part because our z-axis is off. I'm going to zero the z, and I'm going to zero the y. Now if you look at my excuse me, if you look at my field of view graphic, it's in the right location. It agrees with what I'm seeing in my camera window. Very important. Those things should be in agreement because that tells me that the software knows where my part is on the stage. So now as I start to try and auto-generate measurement steps and things like that, it's going to know where to drive to find these features. Okay. The other thing I need to do, though, is I need to take care of the rotational skew. This would be your angle button in MeasureX, or it would be the kind of little angle graphic in MeasureMind, but it'd be the fourth button in your DRO at any rate. And it's our fourth button up here. It's got the Greek theta symbol right there. So if I ever say theta, that's what I'm talking about. And all this is going to do is set our x-axis rotation. So notice this part isn't perfectly square on the stage, and the software doesn't know that. But as I drive down here, it's going to show me there's a little disagreement. So it thinks I'm off register here, but I can see it centered over in my camera window. When I click this angle button or the theta button, it's going to correct that. And now the machine knows where the part is. Okay. So that is one method of importing CAD and aligning to a part. Now I'd go on and write my program. And then when somebody wants to run this program, they can set the part on the stage, hit run, and while that header's up, they could go and find that feature there, 0, X, Y, and Z, and find that feature there and click the angle button. Why did I choose those features? Again, they're simple, easy features to align to. They can be completely different from what your print's calling out for your datum alignment. Okay. For the part setup, we just want easy features for somebody to go and find, easy features for you to describe. And then we'll go back after the fact in our measurement routine and we'll create the alignment that our print calls out. We'll measure the datums that our print calls out. Okay. So two kind of separate things. The other method that we have for creating an alignment is to actually just physically go and measure some points. So I'll click new project again and we'll look at a different method here. So I'm going to import my CAD again, and I'll use the same part. Check it against the machine to make sure it's sized correctly. Okay, looks good. This too, so this will get sent out to all of you. So the other method that we would have would be skipping this manual part setup altogether. So I'm going to turn off my model there and just going and manually measuring some points, right? So it's kind of doing the same thing It would be, again, finding some easy features to align to. I'll probably use the same targets. And then after we do this manual rough alignment to locate and orient the part, we're going to then go back and measure our datum features after that. Okay? So, again, these are rough locations of the part. So, for example, I bring my part in, and I'm just going to hit save. Machine, I'm obviously not in agreement right now with the part and the software and where the actual part is, because in my camera window I can see the part, and over here it thinks I'm floating off the part. So I need to go and measure some features. Now, this is going to work a little differently, because now I'm going to tell the machine, excuse me, the software, where I'm going to measure. And that's the big difference here when we're model-based programming than, say, in Measure Mind or Measure X, because we don't have models there. So I don't address the model, whereas here I'm working from a model. I need to address where on the model I want to measure. So the series of steps is going to be, what do I want to measure? In this case, a point. I have my measure ribbon here. I want to measure a point. Okay, and where on the model is it? Okay, so I'm going to use the same feature. You can kind of see my little vector arrow. It's that pink arrow. If I go down here, it'll point out because this is a 3D geometry, and this little cylinder is associated with this surface and this line and this edge. So the best way to do this is to kind of zoom in. You can use the roller wheel on your mouse and to zoom and translate that image, get close, and move your cursor close to the intersection, but still on the top surface of the part, that top plane. And the reason for that is I want that vector arrow, that little yellow arrow, aligned to my optical axis. What that's doing is it's setting my primary axis, or my z-axis in this case. So I'm going to make sure that I have that arrow pointing up. And now I'm going to grab my crosshair target, or whatever tool I want to use to acquire this point. I'll stick with the crosshair tool. And notice real quickly, I don't want to get too far into the weeds here, but you do have all the same tools you had in Measure Mind or Measure X. Okay, so the manual targets, as well as all the automated targets, and then some additional ones, bonus targets. Okay, so I'm going to go ahead and move my target to the intersection in question. So we can see that I'm still in disagreement, my model window over here and my point over here. And I'm just going to take that point. I can click right in the camera window now, or you can still hit enter on your controller. It says down here, you've registered a point, and I hit save. And now the problem is, I said I measured a point right here, and that point is over here. What we're going to do is we're going to align to that point. I'm going to do that by going up to my alignment ribbon right here. It's okay. John is still on my cursor for a second. And I'm going to go ahead and hit create alignment. I can drop down the list here, but I want to use the create alignment. And I'm just going to either select that point over here, or I can select it out of the routine tree here. Okay. And you'll see when I click on that, it moves my origin right to that point. Okay. The reason that origin is floating, kind of rotating around, is because when I create an alignment and I reference a geometry, in this case a point, that alignment is going to lock down the degrees of freedom that that reference geometry locks down. So in the case of a point locks down the X, Y, and Z translation, but it doesn't control rotation about any of those axes. Okay, which is fine. I just want it to locate. I don't want it to set any kind of rotation. This is a rough alignment. So when I hit save, what's going to happen is that this is going to move to my field of view. Okay, so now I've roughly set where the part is on the stage. It looks like my field of view is in agreement with what I'm seeing over here. And then the other thing I would have to do is take another point over here. So I'll just do that real quick. Again, I'm going to measure a point. So I click on measure a point. It creates a point step, a measure point step. I'm going to address where on the CAD I want to measure. Again, I'm going to get close to the intersection, but make sure my arrow's pointing straight up. You can always rotate it to make sure you're good. And then I'm going to grab my crosshair tool. In this case, it already is using that because that was the last tool I used. And I'm going to come down here and take a point there. Close is good. And I have a point measured. I'll hit save. And you can see, because this part isn't perfectly square on the stage, that even though I said I was measuring a point there, the actual point was right there. So that's what this alignment is about. We're going to actually create an alignment based off of the measured point. So now I'm going to create a second alignment, and I'm going to first reference point 1, which sets my location, and then point number 2, which sets rotation about that location. So it says primary feature, secondary feature, and the primary feature is going to be locking down whatever degrees of freedom it can, in this case, XYZ translation. The secondary feature sets rotation. Once we're done, now we're fully aligned to this part. I could go into starting to measure my features to create my datum alignment. Okay, so these are the two different primary methods for setting up your part. Is it easier to use that traditional part setup? Excuse me, possibly. Some of the advantages of doing it this way, though, is that I can, in that measured point step, I can build in, you know, some manual movement. So if I go back into that step, I can edit it by double clicking in the routine tree here. Brings that point up in the editor. And I can go to that crosshair step and I can say, I want to make this a manual step, meaning the machine's not just going to take off and start trying to measure that point. Somebody will have to manually move it there. But in order for them to manually take that point, they better know where they're taking a point. Again, they've addressed one of the big issues and big questions people always had in Measure Mine or Measure X. Is, can I put an image in there to help describe where to take that point? Yes, you can. Same thing here. Insert an image. Just create the image that you want to use to describe this, however you want to do it, and go and find that image. And then we can say, there we go. Okay, so now that image will be in this step. So when I go to hit run this program, it's going to shoot up my little header here. And since this is manual movement, it just shows me this window, but it doesn't move anywhere. So I'm going to have to manually move to go and take this point. Now, obviously, I could doctor this image to make it a little more descriptive, do whatever I want here, but this is going to be enough information to tell me as the operator, I need to drive to that location to take a point. If I have enough faith that this one point will get me close enough to the second point, I can just make this one automatic, or I could continue to add additional images. So those are kind of our two primary alignment methods. Some of the stuff that might happen when you're importing CAD, though, is, let's start fresh again, and then I'm going to move along so we save enough time for all the other stuff we got to do. I'm going to bring that model in, and let's say instead of measuring this part in the orientation I have it now, I actually wanted to measure it like this. Okay, so if everybody can see that, maybe measuring it in this orientation rather than this, or maybe even just the other side because there's features there or there, right? So the one thing I would want to do before I do either of these part setup methods is I would just want to manipulate the CAD model so that it was at least in the orientation I want to measure it in. Okay? And obviously this can get really tricky when you have some very, very complex models. You know, I've seen some parts that are freeform toroids and stuff like that that don't have any corners, lines, or anything anywhere on them. Then it's a challenge, and that's a challenge for anybody using any software, but those are bridges we like to cross when we get there. So I'm going to import the model. Again, okay. I'm going to turn my machine on so I can see how it imported, what orientation it imported in. And again, now, if I wanted to measure, say, this side, excuse me, measure it in this orientation, then I would have to manipulate this model. So that's why we have this option here in the middle. I can move the model by translating it in X, Y, or Z. You can see it kind of moving there. I can type in some values. I can also rotate the model. Okay, so rotation about the axis. So in this case, I would want to rotate about what axis? Well, I want to rotate it this way, which is my Y axis. Okay. So I can go down here and say, I want to rotate this 90 degrees. And look at that. Now it's down in the machine, but I don't care because as soon as I align to this, it's going to move the model to the right place. But if it makes you feel better, you can kind of get this to where you want it so it sort of agrees with what you're seeing. So now I could go in and either do my manual part setup or I could do my just manual kind of alignment using measured manual points. So those are some options you have there. There's a couple of other options down here, which is reposition via model, which is going to look at the normal view you have right now and kind of skew that thing. It's not the most effective thing. You can reset that at any point in time, and it'll put the model back to the way it was imported. You can reposition via video, and that just means that it's going to trace the outside of your part and try and make the trace agree with the part model. So that would be effective on something like this, perhaps, which is a 2D flat part. Let me put it up by the machine. Oh, that's nice. But it wouldn't be very effective with something like that or my gold part here because they have varying Z heights, right? So my depth of focus is very small and shallow on a machine like this. As it goes around the outside edge of that part, it's going to go in and out of focus, and it's not going to follow that part down and up and around. It'll just stay at one Z height, which means it would go in and out of focus. So it wasn't really designed for that. It was designed for something very simple like this. That other option down there is just a test button they're working on, so you won't see this in your software, and it doesn't do anything right now. So those are kind of some of the import ways you can manipulate the CAD upon import, okay? So I'm going to go ahead and quickly do another part setup again real quick, and then we'll go into kind of creating a datum alignment. Now, the datum alignment we're going to use on this part today is we're going to make our primary datum this top plane here. We're going to make the secondary datum this front plane or this front edge. And then our tertiary datum is going to be this left edge or left plane, however you want to look at it. So we're going to use the optics to create this alignment. But we must start off by locating the part on the stage. Okay, so I've got my models in the software. I'm going to use manual part setup method again. I'm going to choose those same features there, and I'm going to align along the axis here. Good to go. And I hit save. I've got to go and find the part now again. And I'm going to go ahead and find the part. Do a little focus. You do have this focus button up here in this taskbar. And this is just kind of like your manual focus and measure minor, measure X, where it's not going to create a point. It's that if at any point in your programming strategy you just want to do a focus, you can click on this one and then close it, and it doesn't create any steps or anything like that. So I just did a focus. I'll set my Z0. I'll set my Z0. Sorry, one more time. So there's going to be my origin, and oops, right there. And line along that edge. I'll hit save here. And now these things should be live for me. If you're running an older version of the software, by the way, too, anything pre, I want to say 9, you might have to hit the run button in order for these things to become live. So just take that into account. But in the later versions here, they allow me to do it just when I'm starting a program. As long as I'm using a manual tool, make sure you're using a manual tool, crosshair, point entry target. That would be these tools right up here. If you're trying to use the feature finder, that's creating a measured step. So it kind of goes against the principles here. So now I've set my location with the XYZ on this point here, my rotation here. I'm ready to start measuring. Okay, so I need to measure a plane and 2 lines, and then I need to create an alignment from that plane and those 2 lines. So I'm going to use all optics today. We'll in subsequent demonstrations, we'll talk about touch probes and lasers and all that, but we're kind of keeping it simple today. We'll use all optics because I know all of you have a camera on your machine. If not, call me up. That's definitely a service call. Okay. So the first thing I want to measure is a plane. Okay, this top plane we're going to say is our primary datum. And I'm going to go to my measure tree here and say what I'm trying to measure. We're working with CAD, so after I click on what kind of feature type I want to measure, I have to address on the CAD model where that feature is. Now, in the case of this particular part, I have a bunch of coplanar features. And all that means is that this plane and this plane are technically the same plane, but they're broken up on the model. So it's treating them as separate entities. Even this guy is part of it too. So what I can do, and when I'm creating a plane step, I have this continuous feature option. If I turn this on, you'll notice that now it selects all the coplanar features on that plane. I can click on it, and it knows I'm trying to measure this plane. So when I go and measure points and align to those points, it's going to associate those points to this plane. Always my methodology. What do I want to measure? Where on the part is it? And then how do I want to measure it? Okay, so I want to use my focus target. Okay. Anybody who's been in any of my classes, you know full well we need to be at high mag to measure focus points, right? We want our depth of focus to be very small. And I'll show you why that is. Right now, you can see our depth of focus, if I kind of orient this way, this graphic is actually kinematically correct. It's quite deep. So it means any focus point I find in there will be good. That's not the accuracy we're looking for. We're not in the business of close. We're in the business of exact. So I'm going to go to my highest mag, and you'll see this little graphic of my field of view shrink up accordingly. And now it's going to be quite accurate, okay? We're always taking these points at high mag if we're using the focus tool for the purpose of measurement. I'm also going to set my lighting before I go and take any measurements. Now, this is the fun part about ZONE3 is that once I'm aligned to CAD, the machine knows where this part is. Okay, it knows where I clicked. So if I want to take a point here, as long as I have this little exclamation point graphic, also known as the ZOT, I can click and place focus points wherever I see fit. Now, if you try to do this and it's not finding the focus, that means that when you did your little part setup, you didn't focus before you set your Z0. So don't worry about it. It's all about practice and getting better and better, okay? So I'm going to hit run, and with any luck, it's going to go and find those focus points for me, and I can use that to create my primary datum, my plane. What is a plane going to control? Well, it's going to control rotation about the X and Y axes, and it's also going to control rotation along the Z, or translation along the Z axis. Does not control rotation about the Z axis, does not control translation along the X and Y axis. So dust off your old metrology books and GD&T books and start studying geometry types. I also want to call this a datum. Something I couldn't do in MeasureMind or MeasureX is I couldn't call a feature a datum because it didn't matter. I couldn't say I have a position to AB, but it's allowed to float or rotate about one of those axes because I always am constrained. I can do positions to fully constrained alignments in those softwares, but never to an unconstrained alignment. So here I can because I'm working with a CAD model. One of the huge reasons you bought ZONE3 in the first place. You are not constrained by the GD&T you can do in this software, whereas you are very much constrained in MeasureMind and MeasureX. So I'm going to call this datum A and hit save, and we're good to go. Okay. Next thing, I'm going to zoom out. Okay. And I'm going to use this little move to location mode. Everybody see that up here? Once I'm aligned to my part, like I am now, I can use this to drive the machine around. Okay. It will, if I click on the bottom side of this, try to drive down there, so don't do that. Be aware that it is, you know, I've got about a 2.5 inch, 3 inch standoff from my optics to my part, but this part might be tall enough to actually crash into it. So just be careful when you're using this. But now I can set some lighting, and I want to use this front edge here as my B datum, okay? And so, as you all know, if you've been through any of my QBI classes, OGP classes, MeasureMind, MeasureX, what do I want my backlighting at if I'm going to measure an edge? About 50%, give or take 10%. Turn those top lights off. If you have the top lights on, it's going to confuse the edge finders, so let's turn those off. And now I'm measuring a line, okay? I could measure this plane if I had a touch probe, but in this case, we're going to measure it as a line, much the same we would in MeasureMind or MeasureX. Again, our method of creating a step, what do we want to measure? I want to measure a line. Where on the part do I want to measure it? Okay. Now this line is associated with both this plane and this top plane. But for the purposes of my alignment, I don't want to use my vector pointing straight up because my top plane already has a vector pointing straight up. I want to have this control my y-axis. So I'm going to click just below that line on this plane, and you can see my vectors pointing straight out from that line. Okay? I'm going to use that line and this line. And notice now the vector is midway between this edge of the line and this edge of the line, pointing straight out from that surface. That's what we want, okay? And now we need to choose a tool to measure that edge width. So why don't we use Old Faithful Feature Finder? Now we have a couple of options. I could just now start measuring lines like this. But the big difference between Measure Mind and Measure X and ZONE3 is that in those older softwares, I would have to make a bunch of line segments and then construct those line segments into one big line if I wanted to measure this whole front edge. You'll notice in ZONE3, if I say I want to measure a line and use the feature finder like I have, I can add as many little finders as I see fit. So if I add another one right here, it just adds a second line segment. Okay, again, part of the power of ZONE3 here. So now I've got those 3 line segments. If I run that step, it's going to go and measure those 3 line segments. Yahoo. The other option, and this works again when you're aligned to your CAD model, using CAD models, you can use what's called path generation. Okay, this would require me first to have said what I want to measure and then identify it on the model. And what that does when I identify it on the model, it sets all the nominals up for me, so it knows everything about where that edge is. Okay, I also want to have my lighting set correctly before I do this, but I can click on this little path generation button, and I can have it automatically create these finders for me. Now I can turn on this display test path, and it shows me it's going to go from the left side of the edge to the right side. Well, my last focus point was right down in this lower right corner, so maybe I want to reverse that path. And now it's showing me that it's going the other way. Okay? This distance from the ends is, as you can see on this side, this line blends into a radius. Well, depending upon how I manufacture this part, that could be too big of a radius, and it might actually come into the material here. So I might want to just back off a little bit, and you have the option to kind of cheat that away from the ends. There's my millimeter right there. If I increase that number, then it's going to shrink it back a little more. So I went to 1.5, but you get the idea. So we'll leave those at 1, and I'll just say generate path, and now it creates 5 finders for me. I hit OK here, and now I can just run this step out. And it creates this nice, very clean, very uniform looking step for me. I'm going to call this my B datum, okay? So now that our rotation about X and Y are controlled and our translation in Z is controlled, we have to worry about rotation about the Z axis and then translation in X and Y. And since this line is looking this way because of that vector, it's going to control rotation about the Z axis and translation along the Y axis. We still don't have anything locking down translation along the x-axis, and that's what our C datum will do. So for our C datum, we're going to do the same thing we just did in the last step. After I hit save here, we're going to measure a line, and I'm just going to kind of zoom in here and choose the straight lines along this edge. Notice again, I'm putting my cursor just below the line, and I don't want to click right on the line. I want to highlight it, and it's highlighted right now. I just want to click right below it so that my vector stays pointing away from the surface that I want to associate these points to, which in this case is this plane. So I'm going to pick a tool to use, the feature finder, and I'm just going to do that automatic path generation again. I could use a different tool here. I could use the strong edge tool, whatever you're familiar or whatever you're comfortable with. And there's a lot of reasons to use the different tools, but today we'll just use the feature finder for the sake of everybody knowing how it works. I'm going to make sure my path is the way I want it. Okay, so that's the path direction, so it's going to come this way and then this way, and I'm going to say generate a path, and now I can just run this thing out. And now it's going to go and measure that whole long edge. What's so nice about this is one of the big things about Measure Mind and Measure X is we always kind of, not always, but in a lot of cases, we under measure the part because of the time it took to create these steps and the number of steps and the, you know, the clumsiness of it all. There's definitely a learning curve to ZONE3 where you have to unlearn some things and learn some new things. But once you do, it's designed to be a lot more streamlined so that you can contain multiple finder steps in one step and then go and access those and just edit that. So you can see here I've got 12 finders to measure that one edge. And we're going to call this datum C. So I go back up to the step node in my editor, and I call it datum C. And I hit save. And there we are. I've got my ABC, my plane line. And I'm going to create an alignment now and click on A. When I click on A, it shows me that my primary feature down here is plane A. What does A control? Well, it controls rotation about X and Y and translation in Z. But you can see it's shifting in the X and the Y axis and kind of rotating about the Z axis. That's graphically designed to show you what degrees of freedom are still not locked down. Once I add my secondary datum, or the B datum, it locks it up to that front edge. And now you can see why these arrows and vectors are very important, because they need to disagree with one another. So it's saying the only thing left is, for degrees of freedom, is translation along the x-axis, which is kind of showing you there. It's floating along that front edge. And when I add the C datum, now it's sitting in this corner, defined by this plane, this front edge, and this front edge, and it's not moving because it's a fully constrained datum alignment. Okay. I can save that now, and I know that I am aligned dead on to this part, or as well as I can be. Now, is there different ways I could have done this? Of course. I mean, depending upon the sensors I had available to me, there might be different approaches, different techniques, but this is a very straightforward way to do this. And it's not going to work for every part you have, because every part you have probably isn't this gold demo part, but the principles are the same. And that's why, as you start to measure your parts, I would like for you to send your questions and your concerns to me. We can always set up a team view, or even in the middle of a COVID-19 panic, and actually look at what you're trying to do and sort of help you out that way. So don't hesitate. What we really don't want is for people to get frustrated and not use the software. What we want you to do is to use it, because really the only way you're going to get better at it and to learn it is to struggle through some of the difficult stuff at the beginning. And then eventually it'll make a lot more sense, and you can see the power that's there. And this software is a very live software. And what I mean by that is that it's constantly in development, and QVI is pouring the majority of their resources into this software. So it is their flagship. Okay. I think that was a lot to kind of cover there in an hour, and I hope it wasn't too much. Like I said, we are recording this, so I guess I can open this up to questions at this point.